Let's wrap up our unit on equations of lines by looking at part 2 of our review, which is all about equations of lines and how to do calculations with slopes and points to create lines. So I'm going to do the remaining questions 5 to 10 in this section, and we're going to go over all the equations that you need to know for this unit. So I hope you viewed part 1 already. Let's just quickly go over these two sets of equations. The first is the equation of a slope, and we use m to reference slope, and I can see that the slope for m is y2 minus y1 over x2 over subtract x1, and this means that we are given 2 points on the line, and we designate those 2 points as x1, y1, x2, y2. So as long as we have 2 points on the line, 2 points, we can figure out the slope between those 2 points. So now if I look at the two equations that are given to me for the equation of a line, I actually see m appear. And I see m appear in both of these, okay? And it still references slope. So I know that if I need the slope of a line, I can calculate it using this formula that we already know. All right, so what are these other letters? So in the first case, we have b, which we've talked about as the y-intercept, which is at 0b. In our second equation, these two coordinates, or these two variables, y-line and x-line, actually go together. What we're saying is that x-line, comma y-line, is a coordinate, and it's a coordinate of any point on the line. All right, so this has slope and the y-intercept. This equation has slope and a coordinate, any coordinate on the line, and that information can be used to calculate the equation. So let's practice. So what do we have here? This is when our calculator comes in handy. If I put this in my calculator, I will very clearly get an answer of 0. This means our line is flat. In fact, it means our line is horizontal. If I picture my line like a surface, if I put a marble on this surface, it wouldn't roll. It's just a flat line. So let's have a look at this last example. And I'll talk about another common mistake that gets made. So guys, when they look at this, their brain wants to trick them into thinking that the slope here is 0. But again, this is where your calculator comes in really handy, because your calculator will give you an error. And an error does not mean 0. An error means that your slope is undefined. In fact, it's infinity. You don't need to write down infinity. We really want you to say that the slope is undefined. And what that means is the line is actually vertical. It's really hard to define a slope of a vertical thing, right? Like, how do you talk about the slope of this? Well, it's undefined. Determining the equation of a line having a given slope that goes through a given point. Okay, there are two ways we can do this. Two equations we can use to help us with this. My personal preference is to use the second one. So I'm going to use this one first. So what we would do here is we would sub in -1/2 for the slope, and for x-line, comma y-line, we have to sub in the point that we're given. All right, so we get that our equation is y equals -1/2 x plus 5. And if I wanted to, I could sub in 8, 1 in for x and y just to make sure that my calculation is correct. And we would figure out that that works. Okay, so let's go back to this other method, y equals mx plus b. And what we would do is we would also sub in that the slope is 1/2. Okay, and then we're going to sub in 8, 1 for a point on the line. So I've got 1. And what we're doing here is we're solving for b. Okay. And now I have my final answer. We can see obviously that they're the same. My preference for this one is just that in this case you isolate y as your last step, and here you have to remember to substitute b back into your actual formula, and the number of times guys end here thinking that they're done and not getting full marks is cause for a common mistake. So I tend to prefer this equation, but it's really up to you, whatever you like. Okay, so now let's go to number 7. This one is kind of putting it all together. So if I give you 2 points, you should be able to figure out the equation of the line that goes through those 2 points. And the way you do that is always to first, step 1, is to figure out the slope between the 2 points. So here we go. All right, so we know that the slope is -2. And in step 2, we have to pick our favorite equation from above. Okay, and we're going to sub in our unknowns, or we're going to sub in what we know. So I'm going to sub in this point here to -1. It doesn't matter which one you sub in, but I like that one because the numbers are smaller. Okay, and I'm going to sub in my slope that I got from step 1, x minus 2. Oh, and I guess we can call step 3 isolating y. Okay, so here we go, we're isolating y. All right, so I know the equation going through the points 5, -7 and 2, -1 is the line y equals -2x plus 3. And I can always check this if I want. Okay, let's have a look at these next two. So step 1 is always calculating the slope. So in this case, we know that the slope is 0. Now here we go. This is a clue. And we need to go back to what we remember about slopes from number 5. Okay, so this is something that we need to associate with a horizontal line. So we need to know, in the case where we calculate our slope to be horizontal, slope to be 0, we know that our line is horizontal. Similarly, if I ever get a calculation where my slope is undefined, or in other words, a denominator of 0 in my slope calculation, I need to remember that the line is vertical. Okay, so m equals 0. Well, I know that this is a horizontal line. And what did we say about equations of horizontal lines? Well, it comes in a special form, y equals y int. Now, you might look at these 2 points and say, well, I wasn't given the y-intercept. And this is where a little sketch might help. So if you were to graph these 2 points, you would get -4, 6, and 1, 6. And you can deduce that actually the y-intercept of this line would obviously be, it would have to be 0, 6. The y-intercept is 0, 6. So in this case, the equation of my line is y equals 6. In other words, we can look at the y values here and say, since they're both the same, I know my y-intercept has to also have y value of 6. So let's have a look at this last example. So again, we're going to start with slope and see where that takes us. So here I get 9 minus -2 over -1, subtract -1, which is 11 over 0. So we know that our slope is undefined. And if ever our slope is undefined, it doesn't mean that there's no line. That's not what it means. We know that an undefined slope means that the line here is vertical. In other words, our equation is x equals x-intercept. And if I want to figure out what the x-intercept is, I have to look at the points that are given to me. And I can see actually, since both of these x values are -1, I know my x-int is going to be -1, 0. So my equation of this line is x equals -1. All right. So now we're on to one of the last topics, which is how to calculate the x and y intercepts. So we define x and y intercepts as where the line crosses the x-axis and the y-axis respectively. But how do I solve for that? So in blue, let's look at what the x-intercepts are. And the x-intercept, we set y to 0 and solve for x, right? So in this case, I'm just going to simply set y to 0, and I'm going to solve for x. Okay. And in part B, I can do the same thing. I just set x to 0 and I solve for x. So I'm going to bring 7 to the other side, and now I'm going to cross multiply. All right, so we have the x-intercepts of these two lines. Now let's find the y-intercept. As I'm sure you can remember, the y-intercept, to find that, we set x to 0 and we solve for y. All right, so we can calculate the x and y intercepts without graphing by setting x and y to 0, depending on which intercept you're trying to find. Okay, now let's talk about parallel and perpendicular lines. So we know that in parallel lines, okay, the slopes have to be the same. Okay, so if I'm given a list of slopes and I want to know what the parallel slopes are, the parallel slopes are exactly the same as the original slopes. Now, if I want to know the perpendicular slope to something, I have to remember that perpendicular lines, okay, they meet at a 90-degree angle, okay? Lots of us say the word negative or the phrase negative reciprocal. Okay, another way to think of it is that if two slopes are perpendicular, when you multiply them together, the result is -1. Okay, so for example, if I'm looking at the slope of 5 over 4, my perpendicular slope, I'm going to flip the numerator and denominator, and I also have to change the sign from negative to positive. If I'm given -1, remember that this can be written as -1 over 1. So actually, 1 over 1 is the same as 1 over 1, so I can just write this as 1, but I have to remember to change the sign. So the negative reciprocal of -1 is actually +1. Now if I have a slope of -1/2, I know my overall result of my perpendicular slope is going to be positive, so I can just recognize that this slope will be positive. And I can just flip the numerator and denominator, but of course I want to reduce this. I'm just going to write it as 2. So my final result of a perpendicular slope to -1/2 is just the number 2. Okay, so now let's do some problems. We want to determine the equation of the line parallel to y equals -2 plus 3 that goes to the point 5, 8. So essentially, let's say this is my original line, y equals -2x plus 3. If you want to imagine some other point way out here, 5, 8, I want to find the equation of the line parallel to my original line, okay, but going through a different point. So we know that these two lines should have the same slope. So if I first look at my given line, I can see that the slope m is -2. Therefore, my new line will have the same slope. M equals -2. So if I want to find my new line, I know that the slope is -2 and it goes through the point 5, 8. So I can use y equals mx plus b or y minus y line equals mx minus x line. In this case, it doesn't matter what we use. Let's use y equals mx plus b. So I'm first going to sub in -2, and then I'm going to sub in 5, 8. And I figured out that b is 18. So my final answer to this question is y is going to be -2x plus 18. That's my final answer. All right, so let's look at the next one. Determine the equation of the line perpendicular to the given line. All right, so in this case, I have y equals -3x plus 3. And I have some point here, but instead of going through this point at a parallel slope, I want to go through it perpendicularly. Okay, so at a 90-degree angle to my original line. So if I know my original line is -3x plus 3, okay, my new line must have slope that is the negative reciprocal of that, or positive 1/3. Okay, so step 2, I know my new line has slope 1/3, and I know my new line goes through the point -6, 1. Okay, and in this case, I'm going to use the other equation. Again, it doesn't matter which one you use, you should get the same answer. Okay, so y minus 1 equals m x minus -6. Okay, so 1 and -6 came from here. All right, so we get y equals 1/3 x plus 6/3 plus 1, and step 3 is just writing it as our final answer. So 6/3 is 2, and 2 plus 1 is 3. Okay, now let's look at the last question in this section. So if you're asked to solve a system and you're not given a graph, this means we want you to solve the system by equating y values. So let's do a problem like that. So in cases like this, what you want to do is, and actually you could also equate x values if you wanted to, and that dictates what your first step is. So in step 1, you would isolate y in both of these equations, or conversely, if you wanted to equate x values, you would isolate x in this step, but that's up to you. So in this case, what we're going to do is isolate y in both of the equations. So that's our first one. And that is our second one. And if I went too fast for you there, just think about it as moving the negative 2y over to this side and then flipping the left-hand side and right-hand side. So step 2 is to equate the y values. And like I said, if you wanted to use x values instead, at this step you would equate x values. But here we're going to start with this really simple looking thing here that just says y equals y. And what we're going to do is for this right-hand side, we are going to substitute in equation 2 for y. And for the left-hand side, we are going to substitute in equation 1 for y. So we're basically writing out y in two different ways. And at this stage, what we want to do is we want to clear our fractions. And the way we do that is by stating the LCD, which here is very clearly 3. Then we take our LCD, and we don't find a common denominator. What we do is we clear fractions by multiplying each and every term. Even the terms that don't have fractions, we have to multiply each term by 3, and then we can reduce. So let's write one more line to clean all this up. Okay, and now we can simplify and solve for x. So I can see actually that x is a fraction. It's negative 1/2. And we're not quite done yet, because remember, the whole goal of this is to find the point of intersection of these two lines. So I have the x value of my point of intersection, but I need to find the y value. And the way I do that is I back substitute the x value into either equation 1 or 2. Now in this case, 2 looks a little bit easier because it doesn't have a fraction. So I'm going to sub my x value into 2. Okay, so I can see that my y value is 8, and we still have one more step because we haven't officially answered the question yet. To solve the system, remember we have to say what the point of intersection is. So the point of intersection is negative 1/2, 8. And if I want to verify that, I can check to see that negative 158 is a point that exists on both equations 1 and 2. So I can just substitute the x values and y values in to see if the left-hand side equals the right-hand side. So let's just summarize what we did in part 2. In part 2, we used equations, algebra, to solve the system of two equations, and we remembered that the solution to a system is its point of intersection. We also talked about parallel and perpendicular lines. We talked about the slopes of parallel lines being the same and the slopes of perpendicular lines being negative reciprocals. We also determined some equations of parallel and perpendicular lines. We reminded ourselves of the equation for slope and how we calculate x and y intercepts by setting the opposite variable to 0. We also remembered that there are special equations for horizontal and vertical lines, and that we have to know those. We also need to know that a slope of 0 indicates a horizontal line, and an undefined slope, meaning a slope where the denominator is 0, where the denominator of 0 indicates an undefined slope, which indicates a vertical line. Okay, and then we did lots of practice of determining equations of lines, either given a slope and a point, or given 2 points. So we had lots of practice here. So you can find all these notes on our PowerSchool page, and good luck with the assessment, guys.